On this lesson, we are going to see the methods of finding the closed form of a linear recurrence sequence. On the whiteboard, I have the rule of the sequence, which has a first term 11, and the rule is x n plus 1 is equal to minus 0.8 times the previous term x n plus 9. On the next page, I have enclosed the formula that we need to use to find the general form. And the formula of the recurrence sequence is the one you see on the above the line here, is in bracket a plus d over r minus 1 bracket r to the power of n minus 1 minus d over r minus 1. So this is the formula that we need to use. But I need to find what is the A, what is the D, and what is the R. So I need to enter into this formula and get the formula. So the A is the number in front of the rule that is given in the exercise. So the A is 11. 11 is the first term. Is the first term of the sequence. Is x1 is 11. So the R is the negative 0.8. You see, I have also the general rule of the sequence here below. So this is not in closed form, but the above is in closed form. So the rule is R times x n plus d. So the value, the constant at the end is the d, the gradient. If you remember from straight lines, the number in front of the x, the gradient is the r. So the r, you get it from the number we have in the question. And the number is minus 0.8, and then d is plus 9. The a is 11. The a is the first term of the sequence. So if we have these parameters, all we need to do is to go and enter these parameters into this formula. And this is the end of the exercise. We found the general closed form. So what we need to do here is to write x, the closed form of this recurrence sequence. So the closed form is xn is equal, let's see the formula, because we need to base on the formula, which is a plus d over r minus 1. Now the a is the first number of the sequence. The first number is 11. So I write here 11 inside the bracket, of course, because I need to apply the formula is 11 plus d. So I need to see what is the d. Then d is plus 9. Okay, so I can write this as 9 over r minus 1. So the r here is the number in front of the x, which is the gradient normally, which is minus 1. So the r is minus 0.8. Take away 1. I put this inside the brackets, and then outside is the r, which is the r is minus, you know that, so we can write minus 0.8. Right here, minus 0.8 to the power. Let's see the formula, because we need to apply exactly the formula is r to the power of n minus 1. I keep the n because I need to make it as a general formula for the closed form, n minus 1. What is the formula? Plus minus d over r minus 1. So it would be minus, then d is 9 over r is negative 0.8 minus 1, then d minus 1. So whatever it's, so we just write the line here. And all I need to do is to simplify the formula and make it a bit simple by doing some calculation, especially this fraction. To simplify this formula, this fraction, and also at the end, the last fraction. This need to be simplified, and this is what we need to do, basically. So we have, I do some calculations here to simplify the formula. So x and bracket 11 plus 9 over, we do calculations here, and minus 0.8 minus 1 is minus 1.8. 9 divided by this is minus 5, so plus 11. So the bracket, all this bracket goes into 6. Okay, so this will give you a 6. Because it's minus 1.8. If you divide 9 by minus 1.8, you have, and at 11, you have the 6. And by times, basically this 6 times minus 0.8 to the power of n minus 1. I need to do also the same calculation. 9 divided by, at the end, it gives you also a 5. It's a plus 5 at the end. And what we have here is the closed form of a linear recurrence sequence with 6 bracket minus 0.8 to the power of n minus 1 plus 5. It's a closed form because if I know the term, for example, if I want to find the 12th term, let's say I want to find the 12th term. All I need to do is to go and put n 12s. Let's say I want to find the 12th term. 12th term. All I need to do is to replace the n equals 12 here, and this gives you x 12 is equal to 6 times minus 0.8 to the power of 11 plus 5. And this gives you a number is 4.4846. And in case they say what is the long-term behavior of the sequence, for example, what is the value of the term when the n goes to very big numbers, is a possible question. And all you need to do is to examine the bracket and to the power of n this term. So if you want to examine the long-term behavior, this sequence, because we found the closed form, this is 6 times minus 0.8 to the power of 11 to the power of n minus 1. And if the n goes to very big numbers, let's say n goes to very big numbers, to infinity, you expect the bracket, because the bracket is less than 1, to go to very, very small numbers, which is almost 0. So when the n goes to infinity, the bracket minus 0.8, this is 0.8 to the, normally to infinity, goes to close to 0. And therefore, the sequence goes towards 5. Okay, so you can go into from the negative side or from the positive side, because the terms are, it can either be positive or negative. So we just go from the positive side or the negative side. So the sequence goes towards the value of 5. And this is the long-term behavior of the sequence. So it's not difficult when you remember this formula here, because all you need to do is to get the numbers in the formula, the a, then d, and the r. And the a is the first term of the sequence, the d is the constant at the end of the formula, is given, the rule is given, plus 9, and the r is the number in front of the x, is the previous term, so it's like the gradient, which is minus 0.8. And this answers this question. For any comments, you write down the comments. And if you have any topic, you may request a topic and I can cover in the future. And you can subscribe and I can cover this in the future.